Welcome, my dear students. Today I have a story for you. Do you know that? Yeah. In the morning when I move by my car, I want to get a fuel. When I want to get more fuel, I find something, odor. Odor, yes, odor for the benzene. It's very bad. Yeah, for me, do you think what this odor? It's aromatic. Aromatic here it means the organic compound which has a special odor or smell. Today, we'll complete our explanation for the second section for the aromatic, for the organic. It means benzene. Are you ready? Okay, let's see what is the benzene and what its reaction. Let's go. Benzene. Do you think what this means? It's an aromatic compound. I say the benzene cyclic hydrocarbon. Cyclic. Yeah, there is big difference between cyclic and chain open hydrocarbon. My dear, I have here saturated cyclic hydrocarbon. When I say for you aliphatic hydrocarbon, aliphatic here it means I have a cyclic. This cyclic it means different carbon has mean shape. This shape is closed to each other. It means different carbon match with what? With different hydrogen. All of time it's move. This motion back to the motion of electron, but it move in cycle. So we say for this case cyclic, the motion of the carbon in cycle. All of this carbon move. No, the electron move. This help for this molecule to give a special smell. This smell back to the motion of the electron around this molecule. Now you see what happened for this compound. This compound can match, can combine, can react with different compound to make different shape. Look at this. I have here 5 carbon atoms which has a gray color. This 5, it means what? It means pentane. Yes, cyclo. You say cyclic pentane. Cyclic because it's closed to each other. Differ, yeah, the number of the carbon here can be less, can be more. Also, I have here different shape for 4 carbon. Bute, what this mean? Cyclic, yes, cyclobutane. Cyclo, why we say that? Also because all of them closed. This is 5. This 5 it means pentane, cyclopentane. Electron here all time in motion. So the reaction here very fast. And this has a special character, a special smell. This smell is back to aromatic. All of them are aromatic. Cycloalkanes. This is the first type when I say you have a cyclopropane, C3H6. What is the shape of this? You can say cyclopropane structure can be as CCC, 3 carbon atom, connected together by single bond. H1 connected by the other 2 hydrogen. Close to each other, the reaction electrons move for these 3 carbons only. So it's called cyclopropane. This is the motion of the carbon atom. What this move? This motion of electron. As you see, these electrons of the benzene move in cycle. This cycle means what? It means closed in motion. Move in different level. First carbon, second carbon connected by hydrogen. Both are connected by hydrogen. But can electron go out of it? I say difficult. Why? Back to the motion of electron in cycle. I can say also cyclobutane. But 4 cyclo on the cyclic also. When I say that, look at this. I have here what this square. Yeah, it means each side contain 1 carbon atom. You see, carbon, carbon, 3, 4. Each one connected by what? Connected by 2 hydrogen atom. Now you have what? You have cyclobutane. You can catch cyclopentan. Benta, it means what? 5. Now cyclo closed. What this shape? This shape the same. What this? Different size. 5 sides only. Each one contain carbon connected with 2 hydrogen. Carbon, other carbon, third carbon, fourth and fifth one. This shape is called what? It's called the cyclobentane. Why we say N? Yes, good student to say single bond because it contains a single bond. I have here cyclohexane. Hexa, it means 6. The shape here, this benzene. No, this is shape for 6 carbon for each side. As you see, 4, 6. We say hexane. Why this not benzene? Because all of them just a single bond. We can't say benzene here because there is big difference between this shape and the benzene shape. What this mean? Cyclohexane. Unsaturated cyclic chain hydrocarbon. Aromatic hydrocarbon. Aromatic. It means a special odor. As what? As a benzene. Now, we will get a benzene C6H6. It means it contain 6 carbon and 6 hydrogen. You see? What this? Sigma bond? Yes, it has a different bonds. Each carbon of them contain a bond by the shape of hybridized 2BZ. Has a pi bond for some position. It has pi bond, as the scientific will say that. One of them single bond and the other pi bond connected together. Yeah, connected in the shape of C6H6. Aromatic benzene. This is benzene. Yes, it's benzene. Why we say this benzene, not hexane? You can say no cyclohexane according to this. Do you know what this means? This it means the double bond, single bond, double, single, double. So you have here benzene. According to Keckwell, the scientist Keckwell say that. Now I have a naphthalene. Naphthalene. What this word it means? It means I have 2 rings together. It has a single and double. Yeah, 2 rings from benzene together. Give me what? C10. 10 carbon atom connected by 8 hydrogen atom. What this mean? It means naphthalene. Carbon 10, hydrogen 8. It's good for the single and the double. Single and the double for each shape. There is a common between them, common bond between the 2 rings of the benzene. Now I have here different carbon atom. Get the shape of the cycle. This cycle has a lot of hydrogen around it. I ask, what this mean? I see different single and I see different double of the bond between the carbon. This is benzene, you know. All of time it move in the form of the cycle. What it move? Carbon move? No, the electrons around the carbon move. The scientists explained that this motion back to the electron for the scientist Keckwell. Now, functional group. Functional group, very important to catch this word. I have here different type of fruits. You like to catch it. I tell you before, plant, animals have different organic materials. I like different food because it's organic, but I ask, why it's a different shape? Differ for the test according to carbohydrates, fats, proteins, nucleic acid. Organic, yes, it's organic. You see, the shape can be branched as you see. You see gasoline. Carbohydrate, you say this hydrocarbon one carbon surrounded by different hydrogen, all of them connected together in the form of hydrocarbon in the shape of the cycle. Now, when I replace one hydrogen by anything as a Z, it means this Z is functional group may be changed into acid halide, amide, nitro compound, carboxylic acid. This carboxylic, yeah, why we say it's a carboxylic acid? This carbon connected by double bond O, other one O and H, C, O, O, H, carboxylic acid are alkyl group connected together to form the shape formic acid, HCOOH, or anti-acid because it's come from the ants. You have fruits. These fruits, it has a different acids. As you see, different food. As a milk, it means what? Lactic acid. Alcohol. Alcohol, it has a same functional group. It means hydroxyl group. This hydroxyl group, OH, can be substituted by hydrogen, give me one carbon, 3 hydrogen, and OH. It means the methyl alcohol. More of alkyl group. It changes from methanol to ethanol. Ethanol, use it for drinks. Ester. Ester, it means C double bond O. You see, replaced by this O and R, C O. As a fruit, has a fruity smell. This is the ester. You see, C O R and R. Two groups of alkyl ethyl ester. You see, ether. Ether, just one oxygen connected by two group of alkyl R and R or aryl, no problem. Diethyl ether, it means O. Carbonyl compound, C double bond O, it means dicarbonyl compound. Aldehyde or ketone. Hydrocarbon, if it replaced by CHO, aldehyde. CHO, this is a character group for the functional group for aldehyde, can be found in nuts as you see. If I replace it by C double bond O, ketone, yeah, this is ketone. Ketone, C double bond O, as found in the cherry and mushroom. Very important thing. Ketone, aldehyde, formic acid, diethyl, diether, ethyl acetate, and methanol. Everyone differ according to functional group. Maybe nitrogen make a special group as amide, nitro compound. What about amines? Group of amine, it means if you have a cigarette has a special odor. This is back to this amine. Amine NH2. NH3 here connected by three alkyl group. Give me N R1, R2, R3. Primary, secondary, or tertiary amine. You see? This word amine back to N. NH2, this is the main character. Secondary, NH. Tertiary, N only. Now I have C, NH2, methylamine, dimethylamine, and so on. Try tertiary methylamine. Amide. I have here for amide CONH2 found in DNA and protein. Both of them can form acetamide or cyclic benzamide. All of this for nitrogen. Now you have nitro compound. Nitro compound NO2. N, it's mean connected by O and O with the ring of what? With the ring of the benzene trinitrotoluene. This is explosive material. Trinitromethane. Nitrobenzene. This is important for nitro compound. Now you have alkyl halide as R. R bond X. Do you think what this mean? Alkyl halide as halothan. When I say X, maybe fluorine, chlorine, bromine, iodine. When it connected, as you see, it will be chloroform, chlorofluorocarbon, DDT. All of this connection according to halide. Methyl bromide, as you see, all of them back to alkyl halide. What about acid halide? Acid halide by the same C double bond O, R, and X. X here may be fluorine, chlorine, bromine, or iodine, replaced by alkyl group CH3, acetaldehyde. You see, it's very important to say that. Now, halogen, it means acid halide and alkyl halide. My dear students, the reaction here is not a stop and it changes as a gasoline, as you see, according to functional group, which you get character of Z. Can be COO, can be OOH, change from the ether to ester to carboxylic OH, O, ether O, ester OO, and so on. Now, carbonyl compound, I said it before, may be ketone, may acetaldehyde. Functional group contain amine, as you see, amide nitro compound. Functional group can be halogen, alkyl halide, acid halide. Now, benzopyrene found in the cigarette smoke cause dangerous diseases called cancer. Look at this. This is the formula C20 H what? H12 benzopyrene. After that, you have 6 electrons are decollized, as you see. Decollized left to right, right to left, as you see, from the single to double. But I ask, where is the electrons? These electrons found here or here? Or electron here may be changed. This in different position. What this mean? It means electron hasn't a fixed shape, in any shape. So I make some of them single bond and the other it means double bond. Catch this please when I make preparation of benzene in industry. Very dangerous preparation. Here from disodium chloride, I get a beaker, phenol, as you see, phenylamine, and put it in the beaker because it's very hot, sodium nitrite, NaNO2. Also for the third one, concentrated hydrochloric acid. 2 beakers for phenylamine and sodium nitrite. I add it to the flask, as you see, and I wait what happened for this reaction. As you see, the color is changed from the time to time, and I add more. Why? Because I need more and more benzene. To prepare what? To prepare much amount of benzene in lab, not in nature. You know, the benzene found also in the nature, but here I want to prepare much amount of it in my lab. So, I add all of this sodium nitrite. I see the gases that evolve. This has a character smell. What is the name of this character smell? This character smell is benzene. Very hot, you know. I put it in the ice to make condensation. After that, I get this another phenyl and these gases, and I add it to it in condensation beaker to change it from the gas state to liquid state and obtain liquid gas. By all time stir them and add more HCl plus NaNO2, give me nitrous acid HNO2 plus NaCl. This is very, very hot. More stir and stir to concentrate to give me HNO2 to arrive to my preparing benzene. You see? Now I get here different crystals, as you see, from disodium chloride, and I stir them with all of this solution. The reaction here, do you think it stop? No. NH2 with a benzene ring. It means NH2 and benzene ring. Give me benzene ring N triple bond Cl positive and negative. Nitrobenzene. Nitrobenzene from acetamide to nitrobenzene. Give me water vapor. It's evolved. By more stirring and more HCl is added to this compound. Do you think what happened? N here will combine with the Cl by more crystals for the benzenamide. You see, stir, strong stirring. In beaker, just contain ice. By the same reason, why? To change from the vapor state to liquid state and see it well. More and more and more for this reaction. The reaction here is not stop and take a long time and give me high temperature, which can be controlled by presence of the ice. More from this reaction, HCl, all of the group which contain nitrous acid. Now, where is the benzene? Wait and see what happened at end of this experiment. The color is a change, but the benzene not all found. So I add more of crystals, and I wait, I stir, and I wait, and so on. Now, for the end of this experiment, you can catch the benzene as you see. This is very important and a dangerous experiment for you. Take care from this. My dear students, I have another experiment for preparation of the benzene. This also, I have a different tube as you see and the funnel and contain the liquid. This liquid back to CH3COONA. This funnel, separating funnel, contain a different liquid. Now, to work through this liquid, I must get a burner. This burner, and I have here solid materials. This is from sodium acetate. Try to grind it. Grind it, change it from this state of the solid to state of the powder. After that, you have here the liquid added to the compound. What this compound about? We will see. Sodium benzoate with sodium hydroxide. 100 gram and 60 grams for this material. Sodium benzoate. Why I take sodium benzoate for this reaction? Because it has a huge amount of particles that form what? That form the benzene. So, grind sodium benzoate to change it from this crystal state to the shape of powder state. Grinding here very important and need long time for all of this. I wait to change it. What about the sodium? It becomes a powder now. Now you have a benzene? Not yet. I get about 60 gram of sodium hydroxide and also I try to grind it in the same position. To change into what? To change into powder. After that, I add to each other sodium benzoate and sodium hydroxide powder. Stir them. Why? To mix between the compound to give me new compound to be ready to form the benzene. This experiment need a long time. Filling the can more and more of this powder. The can is ready now. I cover it and I put a hole from the top of this. Close it well because I work through aromatic compound which give a special odor. I close it by this stopper and at the end of this stopper it has a special tube connected by this apparatus and I start to heat them. Now during heating there is work between sodium benzoate and sodium hydroxide. There is gas start to evolve. Take care and concentrate. You see when it's full down in this beaker it's condensed and change from its gas state to liquid state. You see sodium benzoate plus NaOH give me benzene, also give me sodium carbonate. It's a very important. Benzene ring OONA, sodium benzoate, NaOH, sodium hydroxide. Give me the ring of benzene. Can be written as you see. H from the top can be, it means it can make a different reaction with anything. Now you have liquid what? Liquid benzene. How do you know? Because I put it in the beaker that contain ice from the gas state to liquid state. By heating? Yes, by heating. But take care from something. I close this can well. Why? Because it's aromatic, has a special odor. At the end, I can see in the bottom some black color Because it's organic compound, don't forget that. It means it has a carbon dioxide during this burning. What you have now? I have benzene. You see, I can separate the benzene and pure it as you see. If you add water to benzene, you can find the benzene at the top and the water at the bottom. I can separate its what? Its impurity, its dirties, because it's not clean. How can I clean it? I add the water, some dissolved in the water, and the other stay. So the benzene is lighter than the water. Why? It's aromatic. Now you have benzene. We can prepare benzene also from the coal tar. Coal tar, it means that during destructive distillation of the coal, it decomposes into gases and liquid. Both of them. Now, we arrive to end of the episode. This episode explained what? Benzene. Benzene ring, aromatic compound. My dear, don't forget, your life around us, organ around us. Now, make a joining between them, aromatic and aliphatic. We can eat both of them, yeah, and some fruits, we can do that. Some food as meat, proteins, it's what? Aliphatic and aromatic. Try to make layer joining between two compound, aliphatic and aromatic, and choose the best one for you. I want you to tell me what is the difference between them and what is the layer between aliphatic and aromatic, benzene and alkan. I with you. Don't be late. See you soon. Thank you and goodbye.